Hello everyone. So today let's talk about this problem which is carpooling. So what this problem statement says that you're given an integer capacity and then you're given a trips array where in each trips of I, what it denotes is that the first value denotes that how many customers are entering and at a given point, and then the second value 1 represents the pickup time, and the second value the 5 represents the drop time. So basically you are given an array in which you have these three information. The information is the timestamp at which your customer or a person is entering your cab, the pickup time, the timestamp at which your customer is dropping off from the cab, and how many customers are entering at that given timestamp. So these three values are given to us, and we have to find whether it is possible to pick up and drop off all the passengers for all the given trips, right? So now let's try and decode this problem, right? So yeah. So if we try to take a look at the first example, so let's try to see what is going on. So okay, so at t equals to 1, so at t equals to 1, two customers are entering your system. So two customers are entering your system, and at t equals to 5, those two customers are dropping off from your system. At t equals to 3, three customers are entering your system, and then at t equals to 7, those three customers are leaving your system, and then you have a maximum capacity of 4. So this is what we are given. So how are we going to solve this problem? So well, what we can do is we can see that there are basically two kinds of events that are happening. So the first event is your pickup and the second event is drop, right? So one thing to observe is that what exactly happens at your pickup and drop events. So what happens is that during pickup your maximum capacity of system decreases, and during drop your maximum capacity of system increases. So now if we try to factor in these, and now let's try and see what is going on is, so at t equals to 0, your maximum capacity is 4, which is given in the problem statement. Now at t equals to 1, 2% have entered your car, right? So your maximum capacity will drop from 4 to 2. Now at t equals to 3, something else is happening, right? What is happening? So 3% have entered your cab, but now we can see very clearly that your maximum capacity is 2, and we are trying to pick three customers, which is not possible. So this setup is not possible, right? So this setup is not possible. Similarly, uh, let's take the third example. So what is happening in third example is that at t equals to 1, and we have a maximum capacity of 4 initially. At t equals to 1, two people have entered your cab, so your capacity will decrease from 4 to 2, right? Now at t equals to 3, they will go, like at t equals to 3 they will drop, but before that, even before that, at t equals to 2, another two people have entered your system. So at t equals to 2, your capacity will go to 0. Now at t equals to 4, but even before that we have a timestamp t equals to 3, right? So I hope you guys are understand that we need to process these events in the sorted order, and that is why this problem becomes the problem of line sweep algorithm, wherein we are going to solve these events based on timestamp, and then we are going to try and process these events one by one, right? So now, uh, as we have already discussed, there are two main events, drop and pickup. And drop is associated with decrease in maximum capacity, and pickup is associated with increase in capacity. By how much? By this much, by the number of customers that have entered your system or left your system, right? So now, and it is very clearly, like looking from like taking a look at this example, it is very clear that we I mean, as in this state, we will not be able to process the event. So what are we going to do is we are going to break this array into another array that we can process. And how? So this array will have two values. The first value will be your timestamp, and the second value will be how many customers, number of customers that have either left or have been picked up, right? So, and another thing that we need is how do we exactly differentiate between, so for example, at t equals to 1, two people have entered your system, and at t equals to 3, those two people have left, right? So how do we differentiate between these two? So whether at t equals to 1, two people have entered, at t equals to 3, two people have left. So how do we exactly differentiate which one is which, right? Whether 1 is associated with pickup or 3 is associated with pickup, right? So what are we going to do is, so for the initial value at t equals to 1, since your capacity will be decreasing, so we are going to assign this 2 as negative 2, and then at t equals to 3, since your capacity will be increasing, so we will be associating this with a positive value, right? So we will be breaking down this array into this. So now how our array will look like is, so how our array will be looking like is this. So 1 comma minus 2, then 3 comma 2, then 2 comma minus 2, then 4 comma 2, then 3 comma minus 1, and then 6 comma 1, right? So this is how our array will look like. But now what else do we need? We also need to process these events in the sorted order. So now what we are going to do is we are going to sort this array, right? So based on this timestamp, right? So this value will come first, 1 comma minus 2, then this will come, so 2 comma minus 2. Now for 3 we have these two values, and this is now one of the edge cases, right? So we have 3 comma 2, and we also have 3 comma minus 1. So which of the values should come first, and how do we decide that? So since this 2 is positive, so this is going to be associated with drop, and since this 1 is negative, so this is going to be associated with pickup, right? So the thing is, uh, we are going to at any given time stamp, what we are going to do is we are going to drop the customers first, and then we are going to pick up the customers, just because we want to maximize our efficiency, right? So that is why uh, drop values will come first, so this will come first. So right, so now 3 comma 2 will come first, and then we will have 3 comma minus 1, 3 comma minus 1. Now we'll have 4 comma 2, and then we'll have 6 comma 1. So this is how our array will look like after we have converted this array and we have sorted this array. And now what are we going to do is we are going to process these events one by one. So at t equals to 0, we have maximum capacity of 4. So we'll have max capacity of 4. At t equals to 1, two people have entered your system, so your capacity drops to 2. At t equals to 2, your capacity drop. Again, two people have entered your system, so capacity will drop from 2 to 0. Now at t equals to 3, 2 and so yeah, at t equals to 3, this is your drop time, not your pickup time, right? So since two people have left your system, our capacity will increase from 0 to 2. Now at t equals to 3, our capacity will uh, again drop from 2 to 1, right? Now at t equals to 4, your capacity will again increase to 3, and now at t equals to 6, your capacity will go back to 4, right? So we see that, in this example we see that at no given time your capacity was negative, and thus this set of arrangement is possible. Let's say at t equals to 3, this would have been like minus 5. So at t equals to 3, our capacity uh, at t equals to 0, our capacity was 0. Now at t equals to 3, your initial capacity goes to uh, 2, and then it goes to minus 3. So if this kind of setup would have happened, then it would have been false, right? So yeah, now I think we have understood how are we going to solve this problem. Let's just try and submit the solution, right? So what are we going to do is we are going to sort this array, and remember we needed some sort of custom sorting setup, so we are going to do exactly that. So we have written our custom logic. So what this says that in case of clash between the first value, what we are going to do is we are going to check whether the second value is greater than the first value or not. And why we are going to do that is because we want to prioritize dropping first and then picking up customers, right? So now uh, we have sorted this array. Now what we are going to do is we also need to transform this array, right? So say result, and what we are going to do is for auto a in a result dot push back. So a of 1, and since this first value will be associated with drop, sorry, pickup, right? So what we're going to do is we are going to assign negative to it, and then your second value, this value will be associated with pickup. So we will have 1 comma minus 2 and then 5 comma 2. So a of 2 and then a of 0. So this is how our result array will look like. And now what we are going to do is we are simply going to loop this result array, and what we are going to do is what should we do, like capacity, we have capacity. Okay, so what we are going to do is we are going to add this capacity with these values, right? So capacity plus equals to a of 0, and if at any given point of time your capacity is negative, then we return false, otherwise we return true, right? So now let's try and run the solution. I just have an intuition that I might have done something wrong in the code. Let's try and run all the test cases. Yeah, it thought so. For false. Okay, so it's going to be 1 comma minus 2, right? So capacity is going to be, yeah, like this is going to be the second value, not the first value, right? uh, let's see, I think this should work now again. So if a of equals to 0, a of 1 is greater than b of 1, otherwise a of 0 is less than b of 0. This is alright. Now sorting a dot and cmp, extract the result. So result dot push back a of 1 comma minus of a of 0 and a of 0 and 2, a of 2 comma a of 0. We have our result nicely done, and then we have this thing auto a in result. It's going to be 1 comma minus 2, right? So capacity plus equals to a of 1, and then if capacity is negative we are going to do this, otherwise we are going to return true. I think for the most part this is going to work. But a dot begin a oh, we should not be sorting this array, rather we should be sorting our result array, right? Result dot, we should be sorting this result array. Result dot begin, result dot end, cmp. Now it should be working. Yeah, it's working now. Let me try and submit this solution. Yeah, so we can see that all the test cases are passing. Now let's just discuss about time complexity, right? So what are we going to, like, what have we done exactly in the solution is we have sorted this array, so that gives us like O of n log n, and then we are simply iterating it, right? So the time complexity is going to be O of n log n, and there's also going to be some sort of space complexity attached with it because we have actually used an auxiliary space. So the auxiliary space is going to be O of n, uh, because we are for all of these, so like for the whole array we are going to uh, so like for every entry in the trips array we will have two entries in the result array, right? So that is how the time complexity is going to be O of n. So yeah, I hope this solution was helpful. Yeah, thank you.